Okay, so today we're talking about the line of best fit. So first we're going to define a scatter plot. A scatter plot is just a graph used to determine whether there's a relationship between data. Basically it's just a bunch of plotted points. So if we look at the table below, it says use the table to complete the following, and A says to create a scatter plot. So we're going to plot the point 1, 3. So over 1, up 3. So run, then jump. 2, 5, over 2, up 5. 3, 8, 4, 9, 5, 11, 6, 12, and 8, 14. So you can see that they don't go in a perfect line, but they do have a direction that they're going in. And just like when you read a book from left to right, we can look at this graph from left to right and see that it is going up. So this graph has a positive correlation because from left to right the data is trending upward. Okay, so now it says to sketch a line of best fit. So you want to draw a line in this graph that fits the data generally. So it doesn't necessarily have to go through all of the points, but you want it to be representative of all of the points, so it's somewhere in the middle. Okay, so I'm going to put a line on my graph. It has a positive slope, and I'm going to try to fit it to the data. So what I've done here is I have sketched a line, and I tried to make it have a nice y-intercept and a nice slope while still maintaining the middle of the data. So if you look, my y-intercept here, and I'm going to put this on D because it says write the equation of the line. So I'm going to say that the y-intercept is 2, and if you look, I've got a nice slope here of 3 over 2. Okay, so the equation of that line, y equals mx plus b, is just 3 over 2x plus 2. So this is the equation of the line that represents this data. It kind of splits it in the middle. Okay, now we need to look at E. It says if the data represents the number of hours you study per class you take, label the axes accordingly. So you need to determine which one is hours and which one is classes. Okay, so the number of hours you study and number of classes you take. So I would say that this is going to be the number of classes that you take. This is going to be the number of hours that you study. So if you take one class, you study 3 hours. If you take 2 classes, you study 5 hours. So the number of hours you study depends on the number of classes that you take. So looking at F here, the y is going to be your dependent variable. Your x is the independent variable. So for this one, your hours depends on the number of classes. So here we'll say number of classes, labeling our axes, and this is number of hours. Okay, so now use your line of best fit to approximate if you were to take 12 classes, about how many hours would you expect to study. Please have that for tomorrow. Okay, so notice that this graph has a positive correlation. Let's talk about a negative correlation. Negative correlation, instead of the data going up, would simply go down. So it could be something like this. And no correlation would not be a positive or a negative, so it could just kind of be all over the place. Okay, so let's talk more about the line of best fit. So sketch a line of best fit for the data and tell whether the data has a positive, negative, or no correlation. Okay, so this one is going down, so it has a negative correlation, which means that the slope is going to be negative. This one's positive, so it's going to have a positive slope. And this one is positive as well, just not as steep. Okay, so what you're going to need to do is you're going to need to find your y-intercept, and then you're going to need to find your slope. And then you write the equation of the line, y equals mx plus b. And we could all have some little bit different answers here, but go ahead and try to sketch a line of best fit for number 1. Okay, so I drew a line in, and I tried to squeeze it right in the middle of that data, and it looks like my y-intercept is here. Now notice that we are counting every line as 10, so 10, 20, 30, 40, 50, 60, 70. So my y-intercept looks like it's about 65, so it's halfway between 60 and 70. And the slope, if you look, I've placed it so that I have some good intersection points here. I've got it crossing at a point here, got it crossing at a point here, I've got it crossing at a point here. So if you notice, my slope is down 1 over 2, so negative 1/2. So the slope of this line is y equals negative 1/2 x plus 65. Now yours might be a little bit different as far as where you drew your line, but we should all have a negative slope and a y-intercept of something around 65. Okay, so for tomorrow, please go ahead and try numbers 2 and 3.